Easy integrals. So I want the integral of 1 over x cubed, the integral of 1 over x squared, and the integral of 1 over x dx. I kind of lied. I said 3 easy ones, 2 easy ones and 1 something that's weird. Did everybody get 2 easy and 1 weird? And I really need you to realize they're 2 easy and 1 weird, right? Because if you recognize there's 2 easy and 1 weird, you're exactly where I need you to be, right? And you're in a place where you're going to learn today easily. So, well, there is no quotient rule, so I have to think of this as x to the negative 3, so that's x to the negative 2 over negative 2, which is going to give me negative 1 over x squared plus c. Everybody okay for that? Everybody okay for problem 1? Okay. Because you rewrite it x to negative 3. When you add 1, that's going to make it negative 2, and you have to divide whatever the exponent is.
Yeah, but what happened?
Oh, well, what happened to the 2? You're right. Thank you. Okay. All right, this one. Well, that's going to be x to the negative 2, so that's x to the negative 1 over negative 1. So I end up with a negative 1 over x plus c. We okay that those are the 2 easy ones? And what happened with the third one?
It didn't work.
Doesn't work, does it? Because when you try to do that, you write x to the negative 1, and then you say, well, if I add 1 to that, that gives me x to the 0 over 0? Right? Everybody okay everybody okay that doesn't make sense? I desperately need you to realize that doesn't make sense. All right? So these look all the same, don't they? Right? Just glancing. You say, well, I'm going to approach it the same way, but something weird happens here. And this is what we're talking about today. How do we deal with this? So now the trick is, remember, your job is to think of something here that when you take the derivative, you get this. You have to go back to January. Can you think of something that when you take the derivative, you get 1 over x?
ln.
Natural log. Do y'all remember that? Does everybody remember the derivative of natural log x is going to give me 1 over x? So it turns out that the integral of 1 over x is going to be natural log of x plus some constant. And this is where taking integrals gets a little tricky, right? Because if you look at these 3 problems, they look almost identical, don't they? Right? But you have to think of something different. Now, there's some clues. Ready? This is the clue. Anytime you have something to the first power, you need to think, oh, my guess is going to be natural log. If you ever see something to the first power in the bottom, you need to think, I need to do natural log. If you see something in the bottom to anything other than the first power, then you can approach it like we've been doing. Right? Now, I do need to talk, I make a shortcut that every math professor is probably going to yell at me. And technically, when you do this, and when you look at the answers in the back of the book and everything else, they're going to put absolute value bars around it. All right? And that has to do, there's a lot of stuff that has to do with it. My very hand-waving explanation is, you can't take natural log of a negative number, so we have to guarantee that x is positive, and putting those absolute value bars guarantees that it's positive. So when you check your answer in the back of the book, all right, or any other place, they're going to you're going to see these absolute value bars. Does the AP exam care? No. Right? In a free response question, if you had something like this and you wrote natural log of x plus c, they're fine with it. Right? On the multiple choice question, if they said, what's the integral of 1 over x, you're going to see the absolute value bars, and they're not going to have one with absolute value bars and one without. So they don't check to see if you know about the absolute value bars or not. And since that's just one level of confusion, I just cut it out. Right? All right, are we okay? So today is about, well, how do you take the integral when you're dealing with natural log? So let's start. Let's say, well, here, we'll start off with 2 easy examples. Example number 1. What about the integral of 2 over x dx? It's out of your book. I figure I'd use it. Guess what you do with the 2?
Just put it in front.
It's just decoration, right?
So it's just 2 elements plus c.
Is everybody okay? This is just 2 natural log x. We treat that 2 just like a decoration, and so my answer is going to be 2 natural log of x plus c. Right? Technically, the absolute value bars, but I'm just going to skip them. All right, next. Kind of easy. 1 over 4x minus 1. What do you do here? Right? Right? Now, anytime you see like a random x in the bottom, like something here, how I want you to think about this, you don't write it. I'm writing it because I'm the teacher and that's what I'm going to do. I want you to think about this as raised to the first power. Can y'all think of that way? When you see this, can you think of this, oh, this is just to the first power? So if you can think of this as just to the first power, then that alarm goes off in your head, oh wait, I'm probably going to use natural log. What would be a reasonable guess? What could I put here that the derivative is going to give me something that looks like that?
Like 1/4.
Oh, don't even worry about the 1/4. If you see this thing in the bottom, your guess, why don't you guess natural log of 4x minus 1?
Oh.
If I take the derivative of this, is that going to give me that? It's going to give me something close. Let's see what happens. When I take the derivative of it, what do I get? So remember how we take derivative of natural log, right? Derivative of natural log. Copy your stuff on the bottom. And you take the derivative of it and stick it on top. So what goes on top?
A 4.
A 4. Is this?
No.
What do we need to do to fix it?
Divide by 4.
Divide by 4 or multiply by 1/4. Either way, right? Since I've got a fraction here, I'm going to multiply by 1/4, and so I multiply by 1/4. And now, do you see we've created something that when I take the derivative, I get this?
Mm-hmm.
And so this is going to give us 1/4 natural log 4x minus 1 plus c. Does this make sense?
Yeah.
All right. What about the integral of x over x? Okay. Notice I don't see any, when I look at this, I think of this as to the first power. If I don't see an exponent on the bottom, right, I think of it to the first power. And if I think of that to the first power, what would be a reasonable guess for this? Oh, wait. My computer is wrong. Oh, someone said, what if you fill out the other form? You fill both forms out. Okay. All right. What would be a reasonable guess? Notice I see stuff to the first, and so my guess was natural log of stuff. Everybody see that? Do we see stuff to the first? What's your guess? Say it louder. Natural log of stuff. All right? So everybody write down natural log of stuff, x squared plus 2. Take the derivative and see how close you get. Everybody write down natural log of stuff. Yeah, you write it. Did this come close?
Mm-hmm. You're off by 2.
All right. So when I take the derivative, I'm going to get x squared plus 2. What goes on top?
2x.
A 2x. Does this match this?
Mm-hmm.
No, what do I have to do?
Divide by 2.
I got to divide or multiply by 1/2, right? So I multiply by 1/2. And so my answer is going to be 1/2 natural log of x squared plus 2 plus c. What if I gave you the integral of x over x squared plus 2 squared dx?
Should just like FOIL it out.
No. Whoa. We don't know how to handle a fraction, do we? Is there a quotient rule?
No.
Is there ever a quotient rule?
No.
Will there ever be a quotient rule?
Mm.
No. You can't handle stuff in the bottom, right?
Right.
Okay. What do you do with this? First of all, does this look similar to this one?
Oh, you just put in the top to -2.
Right? See, if you were to rewrite this is going to give me x times x squared plus 2 to the -2 dx. How do we do this one?
Just
Actually, the question is, do I need to use natural log?
No.
Why? It's got an exponent that's not -1, right?
Mm.
Does everybody see that? That's huge, right? That's the difference. Does everybody understand that? That's the key. Notice how this one is going to have an exponent of -1. Anytime you have something with an exponent of -1, something better pop in your head, I better use natural log. If it doesn't have -1, we can treat this just like we did yesterday on your test. Like, I'm going to look at this and say, well, my guess is going to be x squared plus 2 to the -1, right? Take the derivative and see how close I get. -1 x squared plus 2 to the -2 times 2x. Now, when I compare this to this, what am I off by?
-2.
Here we see I'm off by -2. And since I'm off by -2, right, I'm going to divide by -2. And so my answer is going to be 1, -1 over 2, x squared plus 2 to the first plus c. Gets sneaky, doesn't it?
Yeah.
I mean, today it's going to be kind of easy because pretty much most of the problems I give you are going to involve natural log. But what's going to happen is I said, all right, take an integral, right? And you're going to have to be able to identify when am I using natural log and when I'm not. Right? That's where it gets tricky. All right, are we okay with this? Yeah, let's try a couple more. Let's see. What about the integral of 3x squared plus 1 over x cubed plus x? Is it getting easier to see? Can everybody look at this and say, wait a minute, the derivative of the bottom is sitting on top. Can y'all see that? And that's raised to the first power. So, well, I'm going to guess, my guess is going to be natural log of x cubed plus x.
And that's it.
Does everybody see that's going to give me the right answer?
Mm.
And I'll just put a plus c and I'm done, right? Are we getting the basics of when we're going to use natural log?
Yeah.
First key is you see something to the first power in the bottom, right? Second key, if you see the derivative of the bottom sitting on top, it's good, right? And we just guessed natural log of the bottom, and we didn't have to modify anything here. All right. Oh, what if I gave you secant squared x over tangent x? Let's throw some trig stuff in here. It's kind of like this one, isn't it? Is the derivative of the bottom sitting on top?
Mhm.
Is the bottom raised to the first power?
Yeah.
So what's our guess? What's our answer going to be?
ln of 10x.
So our answer to this is going to be natural log of tangent x plus c. All right, starting getting the idea. Now, in your homework tonight, most of these are going to be involved like this, right? Now, here's kind of a tricky one. Any question? Any ideas? Here's a trick. See, it's all on how you look at something, right? See, if you look at it this way, it's kind of jumbled up, right? There's stuff that's mixed up. What if I were to write this as the integral of 1 over natural log of x times 1 over x? That's the same thing as this, isn't it? Now, what's the significance of a 1 over x? Actually, a better question. What's the significance of a 1 over x when you have a natural log somewhere?
They like correlate, like the integral of 1 over x is.
No, I don't want that. The derivative of natural log of x is 1 over x. Do you see how the derivative of this is sitting outside?
Yeah.
That feels like what we were doing last week, wasn't it? Like, remember you had stuff in parentheses, you had the derivative of what's inside had to be sitting outside? Is the derivative of what's inside sitting outside?
Yeah. So like 1 over ln x squared.
On the right track. The problem is, that's raised to a 1, isn't it?
What would be ln x, and then inside is another ln x?
Here. Everybody take the derivative of natural log x.
Just
Do it. Write down natural log of x. Take the derivative and see how close you get. How close did you get?
1 over x over ln.
Because it's 1 over this times the derivative of that, right? Do you see this is exactly this? And the clue, when I wrote to the net 1, anytime you see stuff in the bottom to the first, you think natural log of the stuff. I'm assuming, is that where you... If you see something to the first power in the bottom, you think natural log of that stuff. And that one's kind of mean, right? While we're on the topic of mean ones, everybody written that down? You might be thinking, what does this have to do with natural log, right? Right? Because everything I've given you so far has been a fraction, hasn't it?
Yeah.
Right? And not only that, everything I've given you so far is a fraction where you have something and then the derivative of the bottom is sitting on top, right? And I just give you this thing called cotangent, right? That's not a fraction. Or is it? What's cotangent?
1 over tangent. Tangent to the negative 1.
In terms of sine and cosine?
Cosine over sine.
Oh, wait, it's a fraction, isn't it? And so this is the integral of cosine x over sine x. Is everybody okay with that? Oh, well, now it's a fraction, isn't it? And is the derivative of the bottom sitting on top? So what's our integral? What's your guess? I wanted something here that when I take the derivative, I get this.
ln sin x.
Does it work?
Yeah, it does.
Did I say the derivative of natural log of sine x is going to give us this? So I just have to put plus c and I'm done. So kind of sneaky, but once you see the trick, does it make sense? Guess what you do if I ask for the integral of tangent? Same thing, right?
1.
There's a little difference in it. Why don't y'all do that one? Why don't I give you the integral of tangent? Here. I'll do that one.
Sine
Write it.
over negative.
Oh, we actually do this because I want to explain the back of the book. So did everybody get this? Works the same way, doesn't it, right?
Yeah.
You rewrite it, and you say, okay, well, this is equal to sine x over cosine x. And you think, oh, okay, well, that's fine. This is just going to give me natural log of cosine x. Does everybody see we're going to need a negative?
Mm-hmm.
Right? So you end up with negative plus c, right? Now, I do need a slight explanation. So if you have a problem like this in your homework, okay, and you say, I did it, right? I got the right answer, right? But when you look in the back of the book, you don't see this. See, when you look in the back of the book, what you'll actually see is natural log of secant x. Don't put the absolute value of r plus c. And you might think I got it wrong, right? Like, this is the answer we came up. Does everybody agree that this is the right answer?
Yeah.
Like, you take the derivative of this, you will get this, guaranteed. But you look in the back of the book and they say this, and you think, well, how on earth did they get this? First, I'm not requiring that you give me this. In fact, I'd prefer if you not. Right? How did they get this? Do you remember properties of logs? See, properties of logs say whatever's here can be an exponent. So that's a -1, and so I can put that up here as a -1. Everybody see that? Cosine x to the -1 is the same thing as, so cosine x all to the -1 is the same thing as 1 over cosine x. And what's 1 over cosine x? Do you see? So if you check your answer in the back of the book and you see something, doesn't mean that you're wrong, right? Just means, yeah, they're using properties, and I'm not going to require you to use those. And honestly, neither does WebAssign. Right? Are we okay with this? All right. Next tricky problem. Very tricky. I want everyone to write down, we're going to be, what is the integral of secant x? Everybody written it down. Now, I'm not going to make you do this on your own because when you see how to do it, you'll say, yeah, that's right. And some of you may say you would have figured it out, but I'll go ahead and tell you personally, I understand why it works. I can teach why it works, right? There is no way I would have come up with this on my own. And to be honest, I don't know if I know anybody who would have created this on their own. Right? Now, before you think that you're going to have to put this in terms of sine and cosine, 1 over cosine, that doesn't really help because you get a cosine on the bottom, the derivative is sitting on top, right? We don't know what we're doing, right? There's no way to go from that. Let's refresh our memory. What is the derivative of secant x? What's the derivative of secant x? Perfect. And what's the derivative of tangent x?
Sine over cosine.
No, what's the derivative?
Oh,
What's the derivative of tangent x?
co-
Secant squared x. Everybody remember those? This is huge, right? We got to know derivative of secant is secant x tangent x. Derivative of tangent is secant squared x.
okay.
Right? Everybody ready? All right. So here's what I want everyone to do. You've already got this written down, right? You got the integral of secant x. We're going to multiply by a fancy 1. And a fancy 1 is the same thing top and bottom. Right? And what I want you to do is I want to put secant x plus tangent x plus tangent x. And then it's the same thing if I do tangent x plus secant x, right? So I want everyone to write that down. Secant x plus tangent x on the bottom. You could say secant x plus tangent x on top, but to prove the point, it'll make it easier for you. We're okay that tangent x and secant plus secant x is the same thing as secant x plus tangent x. All right. So now, let's distribute. And so when I
Wait, how did you know to put secant x plus tangent x?
magic. That's what I would say. I like what I'm showing you. Someone showed me. There's no. I don't know anybody who would have created this on their own. We're just multiplying right now. My explanation is because I'm crazy. So now when we distribute this, let's say on the bottom I end up with secant x plus tangent x. What do you get on top? When you distribute that, what do you get? End up with secant x tangent. Oh wait, I need that. And then plus, okay, that's secant squared x. All right. What do you notice? What do you notice that kind of relates to what we're talking about today? What's the derivative of the bottom?
The top.
Did everybody see the derivative of the bottom sitting on top?
Mm.
And what is your guess? What is your integral whenever the derivative of the bottom is sitting on top?
Just the bottom.
No.
Oh, ln the bottom.
Natural log the bottom. Does everybody see that? Anytime the derivative of the bottom, right, is sitting on top, your guess is going to be natural log of the bottom, which is going to give me secant x plus tangent x. And do you see how the derivative of this is going to give me that? So how do you do it? You got to know that trick, right? How did someone come up with that trick? I don't know. I would not have come up with this. I have some very, very smart friends that I don't think they would have come up with this on their own. Someone did. Do you see why it works? All right. So, actually, I really want to emphasize the fact. Are we okay that any time anytime the derivative of the bottom is sitting on top, your guess is going to be natural log of whatever it is. All right? I really want to emphasize this whole thing. So, actually, I've got to use some real math terms. So, first off, mathematicians, they only use natural log, right? In like theory math courses, they never use log base 10, log base anything else. They always use just natural. They just use natural log. And since they just use natural log, for a mathematician, like in a mathematician's course, they just say the word log. Right? That's what they do, right? So, like if I were teaching a theory calculus course, I'm not because I'm not smart enough, but if I were teaching a theory calculus course, and I gave you something like, I said the integral of, I put a happy face on the bottom, and I put d happy face on top, right? Then this answer would just be log of happy face, right? Because I would only, if I'm using a theory course, I would only use log. I would not use natural log, because those are the same. So I say all of that for this. So, what's the integral of, so I'll put cabin, and then I'll put d cabin on top. What does that equal?
Log cabin.
No, it equals houseboat. What? How does it equal houseboat? Right? Because if you do this, you think it equals log cabin, right? You forgot your C. Yeah, I like that one. Man, y'all are rough. That's the best calculus joke I have. Sorry, it does. That's it. That's all I got. I even recorded it.
I keep the recorder.